So for this problem, we're going to suppose the electric field in some region is found to be kr cubed, r hat, in spherical coordinates, where k is just some constant. So we want to find our charge density rho for part A. So we know that the divergence of our electric field vector is equal to rho over epsilon naught. So we just need to solve for that divergence. So it'll be a gradient dot E, which is, and we know for a radioelectric field in spherical coordinates, to solve for that, it would be 1 over r squared with the derivative in respect to r squared E r. So then we want to go ahead and plug in our electric field in this equation. This respects to r squared. And as given to us, it is kr cubed. So now we want to further simplify and multiply our r's. So 1 over r squared, the derivative respects to r to the 5th k. From here, we finally take the derivative. So it'll be 1 over r squared times 5k r to the 4th. From here we do our last multiplication step, and we end up with 5k r squared. And as we said before, we know that this is equal to rho over epsilon naught. So to find our charge density rho, it will simply multiply times epsilon naught. So we get 5 epsilon naught k r squared. And that's our final answer. Now we want to find the total charge contained in the sphere of a radius big R. So we want to use gaseous law. We know that gaseous law is E surface area, or Q epsilon naught. And we want to solve for that Q. So we simply plug in our E's in our surface area. So we know for a sphere, surface area is going to be 4 pi times the radius, which is big R, squared, and then kr for our electric field, which they gave us at the top, is equal to Q enclosed over epsilon naught. So now we just simply solve for Q enclosed. It's equal to simply 4 pi epsilon naught k big R to the 5th. And that is our final answer. It also asks us to find this in 2 different ways. So another way we can attain the total charge is by integrating the differential change. So we know dq is equal to PDS, or rho ds, I'm sorry. So you want to plug in our values. So we get 5 epsilon naught kr squared, which is our rho, and then surface area dr. Now we simply integrate both sides, and we get Q is simply equal to 20 pi epsilon naught k, or the integration of r to the fourth, dr, which ultimately equals 20 pi epsilon naught k r to the fifth over 5, and then we just divide about 5, and we get 4 pi epsilon naught k r to the fifth, which is the same answer that we got here. And of course, you just want to plug in for our radius. This time it would be big R, so it'll be 4 pi epsilon naught k r to the fifth, which is the radius that they gave us for this problem. Thank you for watching this video.